Okay. Okay, we're gonna get. Yeah, I hope. Can everybody hear me? Yeah, great. Okay, I'm very excited to welcome all of you here tonight to enjoy the talk by Dame Jocelyn Bell Burnell, or Jocelyn, as she prefers to be called. This evening is the culmination of a week-long celebration by UF of the UN International Day of Women and Girls in Science. Jocelyn's visit was made possible through the generous support of the College of Liberal Arts and Sciences, the UF Chief Diversity Officer, the Department of Physics, Biology, Geology, Entomology, and Chemistry, as well as Astronomy, IFAS, the Biodiversity Institute, the Center for Gender, Sexuality, and Women's Studies, the Institute for High Energy Particle Astrophysics, and the Florida Museum of Natural History. At this time, I'd also like to thank and give my special thanks to Steve Eichenberry, Peter Hirschfeld, Katya Macheva, and Laura Blecka, and especially Fran Green, who I don't know is here right now, but all of these people really worked very hard to make this visit possible tonight. Tonight's event also kicks off our celebration of the 40th anniversary of the founding of the UF Astronomy Department. And this celebration will continue with special events on April 3rd and 4th this year, so keep your eyes open for that. And now I'd like to hand the mic over to the Dean of the College of Liberal Arts and Sciences, David Richardson, who would like to say a few words.
Thank you, Elizabeth, and welcome to everybody this evening. We are holding this in the McKay Auditorium in Pugh Hall, which is, we like to think of it as the living room of the University of Florida's College of Liberal Arts and Sciences. I'm glad to see all of you here this evening, and let's just get a show of hands. Undergraduates, raise your hands, please. Terrific. Graduate students, raise your hands, please. Faculty. All others. That's great. You have a terrific crowd tonight. Your reputation precedes you, Dr. Burnell. You know, I teach inorganic chemistry, so I'm a chemist, confession, and when I teach that class, I like to start off with the origin of the elements on the periodic table. It's a wonderful story how all of this around us came about. We are, in essence, stardust. We are the product of the stars, organized, and all 7.7 billion humans on this planet owe our existence to the wonders of astronomy. Those very things that we study in that field. You know, astronomers study this incredible universe, but unlike a chemist or most physicists perhaps, they can't get their instruments outside of the solar system. Just a little bit past right now, but not too far. And the rest of it is done by measuring radiation and now gravitational waves. But these methods have brought this incredible trove of understanding about the universe, and it's why this is such a fascinating field to me as a scientist, but as a citizen who really asks the same questions that humans have asked every time they go into the night sky. So bit by bit, astronomers have put together a picture of the universe in which we live, nature, if you like. And this is really difficult work, by the way. It requires individual talent, but it also requires incredible teamwork. And we see both of those things in every science that is successful in its endeavors. Maximizing the success of a team requires diversification of that team. Of that there is no question, and in fact, a lack of diversity on a team is a loss of talent. Of that there is no question. I congratulate the organizers of this incredible celebration. This is an amazing cap to our week. We need the talents of women and girls to join us in the pursuit of science. And I know that wondrous discoveries await us all. Tonight, Dr. Burnell, welcome to the University of Florida. And I look forward to your presentation. Dr. Latta will provide the introduction. Thank you.
Thank you very much, Dean Richardson. Well, I have to say I'm just absolutely thrilled to be able to introduce tonight's speaker. Jocelyn Bell Burnell is a British astronomer and astrophysicist. As a graduate student, under the direction of her thesis advisor, Anthony Hewish and Martin Ryle, she helped build a large radio telescope for the purpose of monitoring quasars. She carefully and painstakingly analyzed the data from this telescope and found these very unusual sources that were pulsating in the radio very quickly and regularly. These pulsars, which she affectionately called little green men, were later deduced to be rotating neutron stars. Their findings were published in Nature in 1968, and in 1969, Jocelyn received her PhD from Cambridge University. Jocelyn, along with her advisor, are credited for the discovery of these pulsars. In 1974, Hewish and Ryle won the Nobel Prize for this discovery. Now, Jocelyn, in her career, has received many honors and medals. Actually, so many that I can't list them all. I mean, I am truly in awe of this very special person. Some of these include the American Astronomical Society Tinsley Prize, the Grand Medal of the French Academy of Sciences, the Michael Faraday Prize, the Commander and Dame of the Order of the British Empire, and most recently, the Breakthrough Prize in Fundamental Physics, for which she was awarded a $3 million prize. And she donated winnings from this prize to the Institute of Physics for graduate student fellowships for people from underrepresented groups. So she is truly committed to furthering the careers of young scientists. Jocelyn was also a professor for 8 years at the University of London, College of London. She was later a professor of physics at Open University, Dean of Science at the University of Bath, and has been a visiting professor at Princeton and most recently at Oxford University. She has served as president of the Royal Astronomical Society, the Institute of Physics, and the Royal Society of Edinburgh. And this really just is the tip of the iceberg for her very distinguished career. So before we begin, and I know you're more interested in hearing her than me, but I just want to finally take a moment to personally thank Jocelyn for coming here to share her story with us and for spending time with both our undergraduates. She had a chance this afternoon to spend some real quality time with our undergraduates and our graduate students. Jocelyn has inspired many generations of young scientists, especially those of us who don't fit the standard mold. She certainly has inspired me. Through her hard work, perseverance, kindness, and generosity, she has paved the way for many women in astronomy and astrophysics. The example set by pioneers like Jocelyn has been, in no small part, instrumental for the high level of diversity that we have achieved so far in the Department of Astronomy at the University of Florida. So without any further ado, let me please introduce and please give your warmest welcome to Jocelyn Bell Burnell.
better? Yeah, switching it on makes a difference. Thank you. I have had a wonderful day here. I'm so grateful for everybody who has made this visit possible. People have been so kind to me today, and I've met fantastic people. It's been really good. And it's my very great pleasure to be able to speak tonight around the theme of women in science. I'm going to start by telling you a little bit about the lives of 4 women astronomers from various ages. And I'm then going to talk a little bit about what the situation has been in the UK for women in science, going via women in astronomy internationally. So we'll start with some lives, and we'll then get a bit more statistical and political. I'm going to start with Caroline Herschel. Born quite a long time ago. You actually see 2 dates for her birth because they changed the calendar by 11 days during her lifetime. However, she's born circa 1750, and she lived to 98. Born in Germany, died in Germany, but spent a lot of her life in England. She came of a military music family. Father was in the military band, and some of her brothers also went into the military band. And the brother William that she worked with moved to England to be an organist and a composer. She didn't have much of an education because they didn't think it was important to educate girls, but she'd had more education than her mother. She could read and write. And she served her mother by reading things to her mother and writing letters for her mother. Her father advised her that she should not expect to marry. She was not pretty and they were not rich. She should expect to spend her life as a housekeeper for one of her brothers. And she became housekeeper to one of her brothers who lived in Germany. He sounds a fairly poisonous man. She wanted to get a bit more education. Could she learn French? No, she couldn't. Could she learn dressmaking? Yes, she could, provided everything she made was for him, not her. Brother William, older brother William, who'd moved to England, really felt he needed Caroline with him to be his housekeeper. And he finally persuaded brother in Germany to release her, provided he gave the brother the salary of a maid to replace Caroline. Caroline moved to England. She started doing a bit of music with William, but he quite quickly became interested in astronomy. This is the house they lived in Bath. It's this width and 3.5 floors high. To put it in context, that's a small motorbike with a cover over it. And the house couldn't be very deep because you had to get light in. So it was really a very small house. So William develops an interest in astronomy and starts making his own telescopes. He doesn't really understand optics, but he makes lots of different mirrors and sees which one is the best. And that way builds himself quite a good telescope. He's grinding, polishing his own mirrors. Caroline complains that all the cravats are spattered with pitch. It's very hard to get pitch out of a lace cravat. And sometimes he becomes so obsessed with polishing the mirror that she has to feed him his meals, forkful by forkful, while he continues polishing. He sets up a telescope in the back garden and starts observing. This is a view of their back garden, again a fairly narrow house, but there is a special plaque. Here lived scientist and musician William Herschel, 1738 to 1822, from where he found the planet Uranus, March the 13th, 1781. This is the first planet that's not visible with the naked eye. It's the first planet discovered since ancient times. and he discovered it from his back garden. And the plaque goes on. He also discovered infrared radiation in 1800, and his sister Caroline Herschel, early woman scientist, 1750 to 1848, hunter of comets. William had to travel a certain amount, and when he was away, he gave Caroline a small telescope with which she surveyed the sky, and she found comets. She also was his observing assistant. They had quite a good system. You know, when you go out in the dark, it takes a few minutes for your eyes to adjust. When you come into the light, your eyes adjust almost instantaneously. This gives great problems for astronomers who want to be dark adapted to see the faint thing out there, but then need light to record their observations. William and Caroline split the functions. William stayed out in the dark, dark adapted. Caroline sat at a small table some distance away with a lamp and a clock, and William yelled at her and she wrote down the date. She also, during the daytime, wrote the work up for publication, managed the house, and over meal times quizzed William, and that way learnt algebra and calculus. Strong little woman, this one. At that time in Britain, the royal family were Germanic, and they got to hear about the Herschels' work and invited them to come and live near the royal palace and gave William a small salary. So they moved their telescopes and equipment to a place that's currently now quite near London Heathrow Airport, on the banks of the River Thames, and they continued observing. When the royal family had guests, and they didn't quite know what to do with those guests, you know, as happens from time to time, they called up the carriage, bundled into the carriage, and drove round to the Herschel's place to be shown the telescopes. And if William was away, Caroline did the honours, and everybody knew that she understood it all just as well as William. And their visitor book reads like some who's who. It's fantastic. William ultimately married. Caroline felt a bit adrift, went back to Germany, spent the latter years of her life there, and was given these awards towards the end of her life. So these are comets. This is the last good comet we've had in the Northern Hemisphere, Comet Hale-Bopp, 25 years ago. We are long overdue another good comet. But you can't order them up. They come when they come, and it's very hard to predict whether they'll be bright comets or faint comets. You just have to wait and see. So Hale-Bopp was very bright. You could see it from in a city centre. It was really spectacular, but there hasn't been a good one since. But Caroline found 8 of these and became known for her work hunting comets. Cecilia Payne Gaposchkin spent most of her life in Harvard in Boston, but she started life in Britain. She had her early education there. She turned out to be quite a good scientist. She thought she was going to be a botanist. She had an aunt who was a botanist. Excuse me a moment while I just find my water. So she persevered with a rather poor science education and went up to Cambridge. But before she went to Cambridge, her music teacher at her high school was encouraging her to become a professional musician, probably a conductor, maybe a violinist. You may know that music teacher's name. It was Gustav Holst. He probably knew what he was talking about. She resisted the temptation to be a musician. She was going to be a scientist, and so she got a coveted place at the University of Cambridge. Cambridge didn't take a lot of women at that stage. only about, less than 10% the student body was female. And then something happened during her first few months in Cambridge. A friend had got a ticket for a big lecture. The friend in the end couldn't go, gave the ticket to Cecilia. She went. It was a lecture by Sir Arthur Eddington about the eclipse expedition that he had led 1919 to verify Einstein's results. She was totally absorbed by the lecture. She was blown away by the lecture. When she came back to her room, she found she could write it out word for word, and she was so excited by it all, she said she didn't sleep for 2 or 3 nights. She was done with botany. She informed the universities that she was going to do astrophysics. Well, you don't actually inform the University of Cambridge, but she maneuvered herself and did a lot of astrophysics, and indeed worked for a bit with Arthur Eddington. She wanted to go on and do a PhD, and he advised her not to do it in Britain, not a good place for women. She should go to the USA. And so this woman who'd led a relatively sheltered life got on a boat across the Atlantic and came to Harvard, where she'd been given a place to do a PhD. So there is Harvard. At that time, it was believed that the Earth and the Sun had similar compositions. They were made of the same stuff. And she was given a job checking this out using the spectrum of the Sun. So she started her work, and she had trouble verifying this statement. Indeed, she was finding that the Sun was very largely hydrogen, which of course the Earth isn't, and there was no sign of the stuff that we have on Earth. She checked and she rechecked and she rechecked her data, and she couldn't find any fault with it. She wrote it up, but adding in the end, there's probably a mistake in this, but I can't find it. One of her external examiners repeated her work a couple of years later and found exactly the same result. So she showed that the Sun, and indeed almost every star, is made largely of hydrogen, whereas the planets are made of much more solid stuff. She stayed in Harvard. She married a Russian emigre, Gaposchkin, which is how she became Cecilia Payne Gaposchkin. There's a very good biography of her about to come out from Harvard University Press. I was asked to write the foreword for it, so I've read it, and it is very good. So if you're interested in the history of astronomy or the lives of some female astronomers, I would commend the book to you. I've now got to talk physics just a little bit before moving on to our next person. I'm going to be talking about dark matter, but first we have to get a grip on the rotation of galaxies and things. So apologies to those of you who are physics students, this bit will be a bit boring. We have a sun, and we have a planet going round the sun. And the planet keeps going round the sun because its speed of rotation is just right. If its speed of rotation was just too slow, it would have fallen into the sun yonks ago. If its speed of rotation was too fast, it would have flown off into outer space yonks ago. This speed that's just right is determined by having the gravitational attraction equal to the centrifugal force. These are the formula. Simplify them, that's the formula. But I know some of you don't like formulae, so I'm going to work with graphs instead. This is a plot of that critical orbital speed, and that's a graph of the radius of the orbit around it. And it applies to stars, planets going around stars, and it applies to stars going around the center of galaxies. It applies to anything going round something big and central. So just remember broadly this shape of curve. I'm going to talk about Vera Rubin, who was a US scientist, worked in Washington most of her life, died just a few years ago. She was interested in galaxies and the way galaxies rotate, and she started studying how the speed of rotation of a galaxy changes as you move out from the center to the edges. What she expected to find was something like this. So this is a plot of the speed of rotation, and this is the distance out from the center. And in the central bit it's a bit curious, but once you get out, it's broadly flat until you reach the edge of the galaxy, and then the curve starts dropping, like the curve I showed you in the other graph. So she started doing these measurements, and this bit's okay, this bit's okay, this bit's okay, this bit's okay, but the galaxy continues rotating like this. There's no sign of it dropping. Oh, well, maybe she's not really reached the edge of the galaxy. So she goes out a bit further, and there's still the problem. And you get some astronomers who can study the hydrogen gas, and they find that this curve continues way, way beyond the visible edge of the galaxy, flat, 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 to something like this distance, whereas you would have expected this curve to have come away down here by then. So people say, oh, you've made a mistake. Do some more measurements. So she did some more measurements, same result. Look at some other galaxies, same result. The only way you can get this kind of rotation keeping on is if there's more material than you can see. If there's invisible material all the way out here. We suspect there is. We call it dark matter because it's invisible and it's stuff. Dark matter. She had a terrific job convincing people that this was the case. It took years and years and years. I think I've probably said all of that. Once you reach the edge of the galaxy, you expect the curve to drop. It doesn't. So there must be extra stuff providing extra gravity, which we call dark matter. And we've looked at zillions of these galaxies, and none of them are flying apart. So it wasn't that she had a few special cases. There really does seem to be a lot of invisible material associated with every galaxy, our Milky Way included. And we got evidence for it from some other places. Galaxies tend to occur in groups. And in this particular slide, every dot is a galaxy. This is a group or a cluster of galaxies. And this cluster of galaxies is held together by gravity, but the individual galaxies are milling around. And when you measure the speed of some of these individual galaxies, you'll see they should escape. The cluster, the grouping, should evaporate gradually. We see no sign of a cluster of galaxies evaporating. Once again, there must be extra gravity that's not visible. Dark matter. And we got a really clinching measurement of it with this observation. We've got several galaxies clustered together in the middle of a cluster. Every orange thing in this diagram is a galaxy. You can maybe also see some blue arcs going around like that, and a bit of another arc there. Way, way beyond this central cluster, there's an object that gives out a rather more blue light, probably a quasar. The light comes towards us. Some of it that's going to miss this cluster of galaxies, or miss the central bit, gets bent, and we see it as these arcs. So this cluster of galaxies is actually focusing the light through its gravity. And when you work out how much gravity the cluster must have to focus the distant light that way, surprise, surprise, you find there must be a lot of invisible matter. There isn't enough stuff in the galaxies to do that focusing. So we now have to accept that this dark matter is here. It typically makes up about 27% of the visible energy, of the mass energy of the universe, whereas the visible bit that we see only makes 5%. So there's a lot more dark matter, about 5 times as much dark matter as the visible stuff. And we still don't know what that dark matter is. It's absolutely clear it's there, but what is it? We still don't know. We're trying, but we still don't know. There's a big new telescope building in Chile, has been known as the LSST. It's now going to be called the Vera Rubin Telescope. I think this is the first time a major telescope has been named for a woman. So, fantastic. The final woman I want to talk about is Rebecca Elson, who's even more recent. But sadly, she died very young of cancer. She was born in Canada. She spent some of her working life in Canada, some of it in the USA, and some of it in Britain. She was studying the evolution of stars, particularly the evolution of stars in some small nearby galaxies called the Magellanic Clouds. She was also an extremely good poet. And I collect poetry with an astronomical theme, and I have several of her poems in my collection. So I'm going to read you one of them. It's about searching for dark matter, that stuff that allows galaxies to spin faster than they should, that seems to be everywhere. For this we go out dark nights searching for the dimmest stars, for signs of unseen things, to weigh us down, to stop the universe from rushing on and on into its own beyond, till it exhausts itself and lies down cold, its last star going out. Whatever they turn out to be, there be swarms of them, enough for immortality, always a star where we can warm ourselves. Let there be enough to bring it back from its own edges, to bring us all so close that we ignite the bright spark of resurrection. So she's aware that the universe is expanding fast, that it seems uncontrollable. She's hoping there's enough dark matter to halt the expansion. We now know there isn't. The universe will expand and thin forever, and the stars will go out. And there'll come a time when no new stars light, and it will get darker and colder. So sorry about that, but we don't seem to be able to do anything about it. But, you know, make the best of tonight. We now understand the universe to have about 2/3 dark energy. This is stuff that's causing the expansion of the universe that we stumbled over, really, rather to our surprise. About 27% is the dark matter that was holding the galaxies together and so on. We don't know what that is either. And there's just 5% of the content of the universe that is the stars and galaxies and things that we can see. And we've got some grip on that. But if any of you are looking for a job, 68% plus 27%, there's a lot of the universe we don't understand. And it's quite fun chasing it down too. So having described to you the careers of several women astronomers, I'm now going to talk more generally about women in astronomy. And I'm going to go worldwide. There is a body called the International Astronomical Union, a worldwide body for astronomers. And you can be an individual member, and the major astronomy society in your country can also be a member. About 15 or 20 years ago, the Danish man who was at that point the secretary of the International Astronomical Union was bothered because his wife, also an astronomer, had a lot of trouble getting jobs. And he wondered, is this just Denmark? Or does the same thing apply in other countries? And he started collecting this individual membership data separated by gender. And we now have a database that's been going on for something like 15 years, showing the number of men and women astronomers in each country that are members of the IAU. In this table, I've restricted it to countries with more than 200 members so that we don't have too many statistical errors, root n errors. And I have listed them in order of their female percentage. The world average is about 17%, which is not fantastic. The countries that are above the world average: Italy, France, Brazil, Spain, Russia. The countries that are below: Australia, Canada, USA, China, UK, Germany, Netherlands, India and Japan, perhaps not so surprising. Their numbers are changing and changing quite fast, but they're in a slightly different position. The USA has about one quarter, 25% of the membership of the IAU. So it's quite clever of the IAU to be below the world average on this table. USA must pull the average towards itself because it's such a large component. The English-speaking countries, Australia, Canada, USA, UK, seem to cluster at a bit below the world average. Southern European countries, Italy, France, Spain, and Brazil are quite a bit above the world average, and some Northern European countries are below. A very interesting pattern and a slightly depressing picture overall. Now, there may well be some systematic effects. You have to be a tenured astronomer, which means you tend to be not the youngest in your country. And I have to say that it's amongst the younger cohorts that there are more women. Scientific accuracy also requires me to say that for my generation, the fraction of women is going up because we live longer than the men. You have to be nominated by your country's professional body, and there might be some unconscious bias there. So that might affect the overall numbers. And if anybody wants to pursue the data further, this is the website where you find it. So it looks as if Latin America, Southern Europe tend to have higher percentages, that Northern Europe and the English-speaking countries have lower percentages. I do not believe that women's brains are different in those different countries. I think it's telling us something about the culture in those countries and what it's deemed appropriate for women to do, and how much they are enabled or disabled in doing it. I'm told there's similar distributions for maths and physics, but they don't have the same data. They don't have the individual memberships. So this is a rather special database. So what might be going on? Well, there's probably a number of quite subtle cultural factors. It might be that in a certain country, engineering is deemed much more prestigious than astronomy. So the men go do engineering and the women get to do astronomy. So there might be some kind of bias like that. It might be you're in a country where you still live quite near your parents, so that when you have children, parents can help with the child minding and the women can continue their careers. Alternatively, it might be you live in a country where there's a great range of incomes and there are lots of poor women who'd be only too delighted to come in, be your housemaid, nursemaid, laundry maid, servant, cleaner, etc., while you, the wife, go off and be an astronomer. So there's probably lots of different reasons as to why the numbers are the way they are. But it is quite interesting, and it proves that what pertains in your country is not necessarily an absolute truth. And I want to say a bit about what has happened in Britain. It started in universities, where we started looking at the number of women, number of men, and it's gone on from that in interesting ways. And I will bring it back to the USA at the end. There's a sting in the tail of this bit, so watch out. So, we're scientists, we like data. How many female undergraduates do we have? How many male? How many postgraduates? How many research assistants? How many tenured staff? Etc., etc. And it shows that women are in a minority. That won't surprise anybody here. They get more of a minority the higher up you go. So by the time you get to professorial level, women are in a much smaller minority than they are at the undergraduate level, for example. It shows women progress more slowly than the men, that the women don't get promotion as fast as the men. Or as one of my female colleagues put it, they don't brag as much. It also shows that women put in fewer grant applications for smaller amounts of money. And if they're unsuccessful, they wait longer before applying again. And they're reluctant to put in job applications unless really encouraged to do so. So they put in fewer, and they're older when they do so. So, clearly there's a problem with the women. And in Britain for a while we had a program to fix the women. No problem with scientific society, it's the women who are deficient. And the women have to be made stronger, braver, better, etc. And there were actually training courses to help women write better curriculum, better grant applications, better telescope proposals, etc., etc. But there's a tacit assumption in this, and that is that the scientific society in which we all operate is perfectly okay, thank you. It's gender neutral. It's just the women who are lacking. And we gradually came to realize that maybe that assumption wasn't quite right. They tried special funding for women. They created returner fellowships. You've had a year out to have a baby. Do have a returner fellowship and go back to research. And some charming gentleman would say, you only got that fellowship because you're a woman. You're pulling down the standard of the department. You should leave. That has actually happened. So we've got round that in Britain by having this type of funding open to both men and women. Men who've taken a break to look after a child, for example, as well as women. It's still held more often by women than men, but at least the woman can now say, I got it in competition with men and women. And then the funding agencies began to realize that funding individual women to help them was great for the women, but it wasn't making any societal changes. In a sense, it was almost perpetrating the present arrangements. And they began to wonder how good that was. So things took a slightly different turn. They began to look for what's called institutional change, making the whole place more friendly to women, but actually more friendly to all sorts of minorities, trying at the same time, so that it's not just a white man's place, but that people with disabilities, people of colour, people with various gender identities felt it was a place that they could comfortably be. And I want to stress that structures can be sexist even though the people working in them are not. That's really a very, very important point. since you're here, you're probably all concerned about the position of women in science, astronomy. But I don't know whether you are or not, but you could be working in an organization that has some sexist practices. And I'm going to now be talking about institutional practices, and I'm not accusing any individuals of being sexist. I'm looking at the way organizations operate and are organized. So there are various pitfalls where you have a majority group. It tends to assume that its way of operating is the normal and the right way of operating. You know, we saw it earlier, women don't put in enough grant applications and they don't apply for jobs often enough. It's you know. So we started looking at sexism, unintentional, usually sexism, within organizations. And a lot of it is unconscious. And my favorite example of unconscious bias is on the screen. I'm sure you've had to fill in a form, and it's asked what sex or gender you are. A couple of boxes, and you have to tick one. Okay? Which box comes first? Are they in alphabetical order? Why not? This is what we frequently come up against, and it's not alphabetical order. But we're so used to it. At one level we don't notice, but at another level it says to the women, you're second class. And I only noticed it one day when I was filling out a form, and a little gremlin at the back of my mind said, I want to tick the first box. And for the first time in my life I noticed that they're usually, nearly always put in this order. This is the kind of thing that sends subliminal messages to women, which neither men nor women really notice consciously, but do send a persistent message. I once did a piece of work for McKinsey's, the management consultant, business consultants firm, and they've had me on their mailing list ever since, and I get their quarterly journal, which makes quite interesting reading. It was partly through reading that I came to discover that McKinsey's done research in the business world on companies and businesses and which are the most successful. And they've now demonstrated really very clearly that businesses that are the most diverse are the most robust, flexible, and successful. They're also the hardest to manage. The easiest group to manage is a group of people exactly like yourself. But actually, if you can manage a diverse group, it will be far more successful because of its diversity. So diversity is important, and universities need to take notice of this, because universities in many instances could be more diverse than they are, at least in the Western world. So going back perhaps 20 years, I was part of a small group of women that met together after work in our own time in a borrowed room in London to put our heads together and say, how could we make things better for women in science in Britain? And we floundered around. We were all over the place. Until Caroline, who's a bit of a psychologist, had a bright idea. Now I need to do just a moment's translation. In a British university, the equivalent of president is called vice-chancellor. It's really confusing. The chancellor is a mere nonentity. It's the vice-chancellor who does all the work. So Caroline said, you know, vice-chancellors are competitive guys, and they were all men at that point. She said, if we create a competition for the most woman-friendly university, they'll compete. Well, we were poor, but we chipped in enough money to get a glass rose bowl, and we announced the competition, and about 10 or a dozen universities competed. And we gave this glass rose bowl to the university that we judged was the most woman-friendly. And next year we bought another glass rose bowl and we repeated the competition. It got a bit bigger. And we went on like this for several years. And we learnt quite a lot through doing that, I have to say. It became known as Athena SWAN. It's a measure of how woman-friendly is your university or your department. You can do it either at academic department level or centrally university, where you're looking at your university systems and processes. It grew slowly until one day the chief medical officer, Dame Sally Davis, who holds research funds for medical departments, was meeting with the heads of medical schools. And they were talking about the kinds of things that funders talk about with the people they fund. And at the end of the meeting she said, "You're all men, where are the women?" And they said, "Doesn't matter." And she had, as she put it, a rush of blood to the head. And she said to them, "If you want to apply for my money, by the end of next year you've got to hold Athena SWAN bronze." Well, Athena SWAN is what our glass rose bowl scheme became. And we started doing it at bronze, silver and gold level. And we generally got it better organized. And when a funder starts saying things like that, people take notice. No way would they listen to the women, but the funder, even if the funder's a woman, because she's got money, they listen. She forgot to tell Athena SWAN, and they wondered why there were suddenly all these applications. But they did apply, and a number of them got the required level, and she stuck to her guns. And other funding bodies started taking notice. And it's now regular in Britain that the funding bodies require you to hold at least bronze level Athena SWAN. Some say by department, some say university centrally, some say both. And it has taken off. It then got extended to arts, humanities and social sciences, where the issue is not where are the women, but in some departments where are the men. So it's become gender neutral. It's the same issues. Are your processes fair? Are you biased against, unconsciously biased against one community rather than another? And we set up the Athena SWAN thing at 3 different levels, bronze, silver, gold. It's a bit subjective. Your award holds for 3 years, and then you have to reapply. And as I'll explain in the final slide, there is not an absolute level for bronze. It's measured as much on your gradient as on your current level, which is an interesting concept that scientists sometimes struggle with. Not only has it now gone to arts, humanities, social sciences, it's gone to Ireland, where every university was required to hold bronze level centrally by the end of 2019, or no department would be able to apply for research funding. I think there must have been some casualties. The snag is they're not advertised on the web. Surprise, surprise. But that is fierce. That's really fierce. It's gone to Canada. Just coming in Canada. It's gone to Australia. And listen up, folks, it's coming in the USA if Shirley Malcolm at the AAAS in Washington has her way. She's trying to get it brought in here. It's called C change, capital S, capital E, capital A, change. And it's not just women. It's gender and disability and race and all the other dimensions all rolled into one. So you may well find yourselves participating in something like this quite soon. I hope it doesn't come too fast. Once Shirley Malcolm gets moving, try stopping her. So there's been huge change in several countries now in the last 10 years, 5 years. I am waiting for the pushback. I think it's gone really rather fast, but I haven't had much sense of a pushback. There's a bit of grousing, sure, but there'll always be grousing. More forms to fill in, etc., etc. It's certainly making big change in Britain. There are some spin-offs that I'll talk about that are counterproductive, but it's undoubtedly focusing minds. I wonder if it could get overzealous. I don't know, haven't seen it yet, but again, as well as a pushback, I'm worried about it getting over-enthusiastic. I sometimes wonder if this is really the only way you can change society. It's kind of forceful, isn't it? You know, no money unless. But it seems to work. And one of the issues we've had in Oxford is we have a very international community. And whilst we, the Brits, have got used to doing Athena SWAN, some of our academics and grad students from other cultures really struggle. And we haven't yet found a good way of inducting them into Athena SWAN type thinking. It will come, but it's something we've not got properly smoothed out yet. So, it is a lot of work preparing the cases. You're asked for data on how many men, how many women, how many men, how many women at every grade, and how long they've been there, and how much they're paid, and all this kind of stuff. It has forced departments to examine their statistics, which maybe they hadn't really looked at for a while. It has encouraged conversations around gender. Some of the conversations are not very productive, but at least there are conversations. And at last, it's no longer seen as a responsibility of the minority group, the women, to solve. Everybody recognizes that it's part of their department health, and it's not just an issue for the women to sort out. That's a big plus, although I'll present a slightly counter picture in a moment. And we certainly found in Britain that it's helped us deal with other things like getting BME accreditation and LGBTQ plus accreditation, because the methods are rather similar. You need the data. So look out for it if it comes your way. It is called Sea Change. Female members of staff, you might get dumped on to lead your department submission. Just watch out for that. It has in the past typically been dumped on women to do it. We're also finding in Britain that young female postdocs are getting a lot of job interviews. And it's because a department has to say it's interviewing women as well as men. And there aren't so many women. And they're fairly certain that a number of these universities have no intention of giving them the job. They're just called to interview to make up the female numbers of interview candidates. And in Oxford's engineering department, there are relatively few women. Surprise, surprise. And the senior women were being asked to sit on this interview panel, and that interview panel, and this other thing, and that other thing, and that one as well. And they went on strike. So the university trained up some of the younger women engineers, which was actually very good for the younger women engineers. They got the chance to sit with some of the older men on committees and panels, and they learnt rather better how things work. But if it comes your way, some of the women might have to go on strike. And finally, something that I've already alluded to, if sea change does happen, it'll probably follow Athena SWAN. And the subtlety is, this is not a measure of where your department is. It's not an award for being at this level or that level or that level. It's an award for how you are going, for your plan to improve your department's situation. So there's a lot of fluidity in this, and there is not an absolute bronze and an absolute silver and an absolute gold level. And just because you're bronze this year and for the next 3 years does not mean you'll automatically get bronze next time round. You're expected to have upped the game a bit in the intervening years. So I hope you find that interesting. I hope that if sea change comes, you've had some warning of what to expect. It is a lot of work. I do think it's worth it. I think it's made a lot of change for the women in Britain in scientific subjects. I think it requires the threat of withdrawal of research funding for any initiative to work. Sad, but seems to be a fact of life. I won't claim it's a perfect system, but it undoubtedly has led to a lot of improvement in Britain. So I hope if it does come here, your experience of it is reasonably good, and I hope that maybe being forewarned like this will help you prepare or get the mindset ready for it. Thank you for your interest and your attention.
So much that one keen fact immediately after
the which is, the question was, did the numbers I show for the International Astronomical Union data, were they recent? Had they changed? They are the most recent ones available. As I say, they do go up by about 1% every 3 years. So there is improvement, but it's a bit slow.
It works. So, Athena SWAN program started in the UK. Have you seen any improvement in the numbers and the statistics in astronomy or science for women at different levels?
I can certainly real willingness, desire to recruit more women. I suspect the numbers have improved, but I haven't got data on it. But the feel is undoubtedly a lot better. Yeah. Yeah. So you prepare your department or your university submission and you send it in, and then there is a panel that will look at it, and they will be judging several at the same time. So it's like having a grants round or something like that. They collect a number of the applications to judge at the same time. They have quite clearly articulated criteria, which you can probably find on the website. I would imagine if sea change comes here, they will similarly have clearly articulated. Tell you the best thing to look at would be the Canadian website, because that's now up and running, and you know, it's nearest to this country in a sense. It's a long way from Florida, but it's nearest to the USA. Yeah, so it is fairly clearly articulated, I believe. I'm not the best person to judge, having been involved with it right from the beginning, but it seems to be working pretty well. I don't hear too many grouses about it, so I suspect people who submit feel reasonably clear, understand what they're meant to be doing.
Hi there. My question is regarding the women that you talked about. Where did you find them and how can we find more?
Right. Well, for Cecilia Payne Gaposchkin, there's this book coming out very, very soon, and that's a full biography. Caroline Herschel, there'll be a bit on the websites. Rebecca Elson, there's probably very little, but there is a book of her poetry and a bit about her life. And what's really if you're interested in poetry, is it also includes her work developing the poems, and you can see her changing words to make it better, which is really rather nice. Caroline Herschel website. Vera Rubin very recently died. I know there's a biography of her being written, an extensive biography. I don't think it's quite finished yet, but wait 12 months and there might be a book about her. I'm sorry, I'm not hearing you. So the question was there a defining moment that made us, group of women, get together and create Athena SWAN. I think basically what started was, we'd meet up occasionally at conferences, and you can imagine the social hour at a conference, and there's this senior woman and there's that senior woman, and they haven't seen each other for a few months and they're trading stories. And this goes on a bit, and finally they say, we really ought to try and do something about this. I don't know which of us convened the group originally, but having got together this group of 6 or so people, its membership floated a bit. Sometimes we'd be about 8. We were clear, all of a mind that something had to be done, that we couldn't just continue the way things were, that scientific society needed some kind of prod to, and I don't quite remember what that was. It may just have grown gradually, and we finally articulated it for ourselves and then began to think up about a competition.